Hello, hello, hello. Good evening, my lovely warriors. Welcome aboard to the Pathfinder series for all the 12th standard as well as the dropper students. And today we are going to do electromagnetic waves via NCERT. Underline, I'm going to give you all the important points of NCERT. We are going to quickly brush up through all the things which are there in this chapter. Also, we're going to scale up to JEE mains level because this chapter is only there in JEE mains. Keep that in mind. Also, probably your local CETs, depending on which state you are in. And we are also going to do some amazing problems immediately after the NCERT underline. So all of this about electromagnetic waves in one shot, and in case you have missed the first class, you can definitely check it out in our you know playlist out there. So definitely do check it out. And those of you who do not know me, this is Shreyas here, your captain for this channel. And my dear warriors, I've been training for almost like a decade now, and I'm here because I love teaching, I love physics, and when I wrote my JEE, I almost got full marks in the JEE examination physics paper. And I have been training all the top-notch ranks for a long time. You can think of all the big names, and probably I would have worked there. So let's get started with today's session. And yes, before we begin, do not forget to smash the like button out there. Hello Sankar, hello Light Up, Sravanan, welcome Nishita, welcome Barney, hello Bhavesh, hi Saja, Swekar, good evening, bacha log. Nice to see all of you joining in for this session out here, a very, very important session. Do you know that this chapter is important plus easy from JEE perspective? And this is a term 2 chapter, probably the first chapter of term 2. I hope you are aware of that. And how many of you have already done this chapter in school? How many of you have seen my lecture 1 of Pathfinder series where I had taught this chapter in detail? Please do let me know in the comment section. Please do let me know in the chat box. Hi Ankit, hi Sankar. So the thing is, Sankar, like I had mentioned, I'm right now not in my studio setup. I'm somewhere else. So that's the reason why I don't have the smart board. Very good, Sweta. Shruti also done. Very good, Sankar. Excelente. And those of you who have, let's say, not yet seen it, what you can do is go to the playlist section and just search for, Pathfinder series. You will get the playlist. It's there. Okay, just check it out. Lecture number 1 of electromagnetic waves. So let's get started with the class today. And let me also remind you, if you want to cover the entire JEE syllabus, then you obviously have the JEE crash course, 90 session crash course with 20 mock tests and also assignments for each and every chapter of PCM, along with live classes and the recordings along with doubt solving. It's all there for 9,000 rupees. There is a link which is there in the description box. Go ahead, check it out in case you want to take the help of the JEE crash course, which has been the key factor for producing amazing ranks over the past few years for all the JEE aspirants. So all the ranks that you see below 10,000, 20,000, 1,000, 2,000, many of these students were crash course students, and many of them have improved their scores because of this course for 90 sessions. So go ahead and check it out. So I hope you have your NCERTs with you. So please open up your NCERTs because now we are going to go to the NCERT. Ready, get set, go. Have you smashed the like button? Yo, please put up a thumbs up if you have already smashed the like button and you have opened up the NCERT in front of you. Let's quickly go through all the pages. Okay. So Bhavisha, I have already completed light waves. For 11th standard, yes, the sound waves I'll complete it after thermodynamics. All right, Bhavisha. Okay. So MD Rias, it's going to be done tomorrow, bacha. Thermodynamics. Yep. So thermodynamics 11th standard class tomorrow. Yep. Zayed YouTube, long time no see for you too. So open up the chapter and I will be opening it up on my end as well, right over here. Okay. So yes, I hope you guys can see it. And let me just probably put myself somewhere here, maybe. Oops. Once again, no, not here. All right. Maybe here. Okay, sounds good. Okay, fair enough. So great. Let's start seeing all the important points in this chapter out here. And in the introduction part, not much, but what you should know is over here that Maxwell was the guy who gave those equations for proving that light is an electromagnetic wave. So Maxwell is that person who gave the four famous equations, and until then people used to think that light was a particle. They used to believe in the old theory of Newton, and then Maxwell said no, light is electromagnetic wave, and he proved it. There are also other scientists who were involved like Hertz and all, but yes, Maxwell was one of the main scientists out there. All right, so another important thing is that yep, just one second. Yep. Okay, so let's go to the first point over here, that is displacement current. I hope you guys can see it. Or ray optics will also come, Firaz. Yep, it will come later on after this. Yeah, we have to do all the chapters one by one. We'll do everything, don't worry about it. Okay, now what is this displacement current and how is it different from your normal current? See, I will tell you a simple thing. Okay, and I'll just write it over here maybe. Okay, so I'll just write it over here. Normal current, what happens? Your electrons flow. So when the electrons flow, that is called as conduction current. What is it called? It is called as conduction current. But whenever you have electric field, there is no charge, there is electric field, but it is changing. That means it is not constant. I'm writing it on the left top corner. It is not constant. Then it produces around it, okay, it produces around it a magnetic field. What does it produce? It produces magnetic field. Just like when electrons flow, it produces magnetic field around it. Same way, when electric field changes, it's a function of time, then it produces magnetic field around it. So that equivalent current, I'll repeat, that equivalent current which produces the same field as that of your normal current, you can think of it like the displacement current. So what is displacement current? It is the equivalent of your normal current which produces the magnetic field. Okay, so remember, when electric field is constant, let's say you have a charge, it will produce a field around it, electric field around it. Everybody agrees to this. But if the charge moves, what will happen? The field will also change. And if field changes, what happens is it produces magnetic field. So that's the logic that you should keep in mind. And Maxwell and other scientists found out that whenever charges oscillate, move around, then electric field changes, and the moment electric field changes, it creates magnetic field, and then you have electric field and magnetic field, and that's nothing but your electromagnetic wave. That's why this part is there at the start of the chapter, to give you an idea that, hey, listen, electric fields can create magnetic fields also create electric fields. I hope this is clear. As for us, it's a one shot. It's a one shot. Do you guys get it? Everybody cool till this point? Yep. Now this was your usual Ampere's law. This was your usual Ampere's loop law. This was your usual Ampere's loop law. But there is something missing in it. And what is something missing? And if you remember what was Ampere's law, you draw a loop, you take a path, and you go around that path. You go around that path. Let's say you go around this path, something like this. Okay, so this is your path somewhere over here. And if you remember correctly, then there are some current carrying loops over there, current carrying wires inside that path, I1, I2, etc. So integral of B dot dl, B at every point dot dl gives you mu naught into I. This I is nothing but your enclosed current. This is your enclosed conducting current. This is your enclosed conducting current. But if you draw a path around electric field, I'll repeat, there is no current. You draw a path around electric field, then what will be the current enclosed inside? Think about it. If you draw a path around electric field, will there be actual conduction current around it? Think about it and let me know in the answer, in the chat box, guys. If you draw a path around electric field lines are there, and you draw a path around it, Do you think there will be actual current around it? Yes or no? No, right? There is no actual conduction current around it. But we know an electric field which is varying produces a magnetic field around it. I just told you over here on the left top corner. So if changing electric field produces magnetic field, then I need to modify the definition of Ampere's law. I need to modify the definition of Ampere's law, and that's why we have defined displacement current, which is equivalent current which produces the same magnetic field. All right, so it is the same current which produces this equivalent current which produces the same magnetic field. So there is a whole bunch of derivation out here which I have done in detail in my lecture 1. You can watch it definitely. Okay, so just please have a look at it. What is very important over here is this definitions out here. The current carrying by conductors due to the flow of charges is called conduction current. Okay, and the current given by equation 8.4, the new term due to changing electric field, is called as a displacement current, and this is the definition over there. All right, and the formula for displacement current is right over here. Okay, this is the formula for displacement current. Okay, this is the missing term. Like you can see, this is the missing term in the Ampere's loop law. Remember, on the top I had told you about something which is missing. Right over here I had told you, right over here I had told you there is something missing. So that's exactly the missing term right over here. I hope you guys are able to see it properly, guys. Okay, in case you're not able to see it, I'm just zoomed on it a little bit. I hope that is fine. Okay. All right, so if this much is clear, okay, if this much is clear, maybe I can just make it myself small. Okay, or yeah, just 1 second, I'll just make myself a little bit small so that you guys can see me while I'm highlighting all these things. All right, all right, so these are the important things that you should know. Now here is the thing. See, whenever you are talking about Ampere's loop law, the final form, this is the formula that you're going to use. This is very important. You can see there is some extra term over here, because usually it was mu naught IC, but you see this is basically your extra term, and that's why you are now no longer calling it as Ampere's law, but you're calling it as Ampere-Maxwell law because of that extra term out here. That extra term, okay, that extra term is basically your displacement current. Keep that in mind. That extra term is nothing but your displacement current, ID. So whenever you talk about the RHS, in your RHS, you have mu naught into I total, that is conduction current, plus what do you have? The displacement current. That's what you can see over here. Okay, so if you take it, if you take mu naught common, you can see it will be IC plus epsilon naught d phi by dt, and you can see what is d phi by dt. D phi by dt into epsilon naught, that is your displacement current. Okay, so what is epsilon naught? Epsilon naught right over here is permittivity. D phi by dt is rate of change of flux. So you can see that right over here. This is rate of change of electric flux. That's why that symbol E is there. Electric flux. So changing electric field causes magnetic field. That's what you should remember. Okay, so keep this in mind. All right, now next, going ahead. Okay, all these are fine. These are just the explanation. Okay, so these are this is one important paragraph which tells you about, so the electric field which changes gives rise to magnetic field. From Faraday's law, you get that magnetic field gives rise to electric field. So this is one important line out here. Which law gives you what? Faraday's law. It tells you when magnetic field changes, it creates electricity. Do you remember? Or maybe you would have forgotten term 1 syllabus. Faraday's law told you when magnet moves, then it creates changing magnetic flux. That changing magnetic flux creates electric field. But Ampere's Maxwell law, what is it telling? Changing electricity, changing electric field creates magnetic field. So they both are related to each other. Bhavisha, next week, yes, after after Sankranti, after 14th, I'll be back to Bangalore. Hello, Sri Lanka, welcome aboard. Yep. Okay, I hope this is all fine. Can we go ahead? And these four laws are basically your important laws in different ways. You can see this is Gauss law. This is just something which is more like a revision. This is Gauss's law. The second one is Gauss's law in magnetism. B dot dA is always zero. Why is this always zero? How many of you remember it? How many of you remember it? Okay. No, Faraday's law is not deleted in term 2, bacha. It was there. Okay. As for CBSE. All right. So B dot D is 0. What does this imply? Do you remember it? This was basically monopoles do not exist. Monopoles don't exist. Remember that? They don't exist. That was the whole implication of that being 0. This is your Faraday's law. And this last one is what you just saw right now. Ampere's Maxwell law. This is what you just saw right now. Okay. Yep. Very good. So these are very easy to remember. There is nothing new over here. The only thing which is new over here is the last one. Okay. Apart from that, everything you know. Have a look at the example later on. Okay. This example has come in different ways in JEE mains. Okay. This is very important from JEE and board perspective. Both. So please have a look through this example. Okay. Now, electromagnetic waves, what are the sources? Well, it's simple. This is the important paragraph. Consider a charge which oscillates with certain frequency. So, accelerated charge, what does it create? An accelerated charge will create magnetic field, and because the electric charge also has electric field around it, and the changing electric field creates magnetic field, you get basically electromagnetic wave. So this is the origin of electromagnetic wave. And the frequency of the wave is obviously the frequency of that oscillating charge. Whatever is the frequency of the oscillating charge, that's exactly the same thing. Welcome aboard. And guys, do you know whatever I'm highlighting here, you'll also be getting it as a PDF in the Telegram group. So yes, simultaneously you can highlight, but in case you miss something, do not worry. I'll be sharing the PDF also with you. Do you like it? Yep, you want it? Please put up a thumbs up. Okay. Now, going ahead. All right. So yes, let's move ahead, and these are the important things for electric field and magnetic field. Electric field wave equation, magnetic field wave equation. This is very similar to your wave equation in 11th standard. Remember wave equation in 11th standard, y is equal to a sine kx plus or minus omega t. Exactly the same thing. Yes, exactly the same thing. So it's one and the same thing. I hope you guys understand it. So what is E naught? E naught is the field amplitude for the electric field. B naught is magnetic field amplitude. K, remember it is the angular wave number. Okay, this is nothing but angular wave number. Very similar to what you have studied in 11th standard. Angular wave number. I can see a lot of thumbs up out there. Very good. Proud of you, bachalo. Omega is your angular frequency. You can see that again the same thing as what you have studied back in 11th. And obviously you can also say omega is 2 pi f. You can also say omega by k is equal to c. Also c happens to be equal to E naught by B naught. Okay, so it also happens to be E naught by B naught. Keep all these things in mind, which is also E by B. E by B is instantaneous values. These are instantaneous values. These are basically your amplitudes. These are nothing but your amplitudes. Both the ratios will give you the value of speed of light. Tanishq, I have been mentioning that my board is not there because I'm not in town. I have come to my hometown. That's the reason why I don't have the board right now. Okay. So, oh, I think my head was blocking it, but I've just shifted it on the top. So now you can see it. Fair enough. Moving ahead. Okay, so all these definitions, okay, are there right over here. The speed of the propagation wave is omega by k. Okay, moving ahead, all these things are fine. Now this is another important formula. C is 1 by root mu naught epsilon naught. Very important equation. You cannot afford to forget it. Okay, C, speed of light, is 1 by permittivity of free space into permeability of free space, the whole thing under the root. Very, very important. And this is also your standard equation. Lambda into frequency is wave speed. Very, very standard. And this is something which I already gave you. C is E by B. So I have already given it to you on the top. So no need to remember it separately, but I'll just highlight it right over here. Okay, so these are all important things. So it's there, so I'm not blocking it again. Okay, and remember one thing, that these waves can travel even in vacuum, so they do not need material medium. That's why they are non-mechanical waves. Like sound waves, waves on a string, they are mechanical waves because they need matter, they need some medium for them to propagate. Keep this in mind. All right. Also, remember this concept about ether. Ether was proposed by earlier scientists and physicists, that there is something like ether which is present all around us, even in vacuum, for light to propagate. But uh, in late 19th and 20th century, it was then proved that you don't need anything like ether or any medium for the light to propagate. It can propagate even when there is nothing around, that means vacuum. So ether was a hypothetical concept, but it is no longer there. You don't need it. All right. So what happens if you change the medium? If you change the medium, then the speed of light will also be different, and that's why you can see the speed formula for light in different medium will have mu and epsilon for that respective medium. So for different medium, you will use this formula. You can see that naught is not there. The reason why that naught is not there, because the medium is different. It is the permeability and permittivity of that medium. Okay, I hope this is clear. You can also calculate refractive index. In fact, there is a question on that as well. Okay, speed of light is 3 into 10 to the power 8 meters per second. That's standard. Everybody should know this. In fact, that also forms the basis of SI unit. Okay, that's the basis of SI unit. That's how time and all of that is defined. Okay, so C is such a strongly fixed number. The unit of length can be defined in terms of C and the unit of time. Okay, very, very important. The unit of length, if you remember, is defined based on the speed of light. That was first chapter of 11th standard, because it is fixed. It does not change with time. It does not change with your relative frame. It does not change from one planet to other. It's such a standard fixed quantity, universal quantity. That's the reason for that. Okay, now this passage also talks about the radiation pressure. Does light waves carry energy? Do they have momentum? Yes, they have momentum, and that momentum and that energy is basically defined right over here. So an electromagnetic wave carries energy and it also has momentum. That momentum, when it is imparted onto a surface, imagine light striking a surface, light hitting your face or a mirror, that light will obviously impart a momentum, and that momentum which is going to be imparted, that is going to create some impulse. That impulse per unit time, per unit area, is basically called as radiation pressure. What is pressure? Force per area. What is force? Change in momentum per time, or basically impulse per time. So that impulse per unit time, per unit area, is that radiation pressure. Okay, so keep this in mind. Very, very important. So I'll just mention over here. So light carries momentum, so it can impart momentum, and because of that there can be impulse, and that impulse, all right, per unit time, per unit area, that is called as that pressure which is there. Okay, because that top part, that is nothing but the force. Impulse per unit time is nothing but the force. Now, how much is that radiation pressure? This is the formula. P is equal to U by C. Okay, so if U is the energy which is transferred, okay, in time t, then it is U by C. Please keep these things in mind. All right, very, very important. But this is only for absorption. For reflection, that P will be equal to 2U by C. This is for reflection. Why 2? Why 2, guys? Why is it 2 times for reflection? Because if you remember 11th standard momentum and collisions chapter, if a ball goes and hits the wall and stops, change in momentum is mv. But if a ball goes and hits the wall and rebounds back with the same speed, then the change in the momentum is 2 mv. That's the reason why. That's the reason why it is 2u. I see. I hope this is clear. Priya, my blessings are with all of you, bacha, and that's the reason why I'm here in the first place. Okay. Hello, Vishal. Yep. So let's get moving ahead. Should we make notes of this? Well, yes, you should add it to your notes which you have made in your handwritten form, and you will be getting my handwritten notes. This entire NCERT handwritten, Shreyas sir's handwritten notes, you are going to get it in the form of PDF after the class. For that, you need to join the Telegram channel. All right. Now, this is also the reason why your hands feel warm when sun falls on it, because light is transferring momentum. Also, it is transferring energy. Very, very important. Okay. Now, moving ahead to the next few important points over here. Okay, there is one more important formula which I will give it to you right over here. You can write it down as well. Intensity of light. What is intensity? What is this I? I is basically your intensity of light. Okay, intensity is basically having the units of watts per meter square, energy per unit time per unit area. That intensity of light, okay, it has this formula, half, okay, E naught B naught by mu naught. Very, very important formula. In case you have forgotten about it, please remember this. Very, very important. Okay. Vedic Goel, I'm not in Bangalore, but I don't have the studio. So please understand, I'm in Pune right now. So that's the reason for that. And one more thing. Yep. Energy density. Do you remember the formula for energy density for both magnetic field and electric field? Energy density for electric field is half epsilon naught E square. This is joules per meter cube unit wise energy density. And energy density of magnetic field, that is half B square by mu naught. This is again joules per meter cube. Okay, this is energy density of the field. And remember, the energy in electric field is equal to the amount of energy in magnetic field for EM waves. Keep this in mind. The amount is equally distributed. It's not like all the energy of the light is there in electric field. The energy is equally distributed. Balaji, like I have mentioned before, I'll be doing it this week. All right. I've already told this again and again. So don't keep spamming. All right. The speed of light is constant. Then how the velocity of the light vary in different media? Dinesh, the speed of light is constant irrespective of the frame of reference for vacuum only. But if the medium changes, then the permittivity and permeability changes. So if you go to this formula over here, remember this formula, okay, this formula, all right. So mu naught and epsilon naught are dependent on medium. They are not dependent on the frame of reference. So when you change the medium, that's where speed of light changes. I hope that is okay. Moving ahead over here, all right, and all right, these are all standard things. These are examples which you should obviously keep in mind. Electromagnetic spectrum, this entire thing should be by heart. Everything you should know, this entire table. Okay, this entire thing, you should know the rough, you should have the rough idea of the wavelengths. Okay, if not the frequency, either you know frequency or you know wavelength, because if you know wavelength, you can calculate frequency because you know the speed of light. And you should know that violet light is the shortest light from 400 nanometers and red light is 700 nanometers. Which are the important points? You should know this. Okay, you should know this 700 nanometers. You should know 400 nanometers is for violet. If you know that, you know for yellow it is in between. That is fine. So 400 to 700 you should know. You should know for X-rays. You should know for gamma rays. You should know infrared is below visible, ultraviolet is on the other side, it's below violet, infrared is above red, of course. And radio waves, long radio waves will be in meters, there is nothing great about it. And microwaves will be in the range of 10 to the power minus 3 meters to 10 to the power minus 4 meters, around that. Okay, so these are the things which you should definitely know. I have already highlighted it. Okay, yes. So dimensional formula of Weber, how do you calculate it? So you can use different ways. Basically, you can use E is equal to d phi by dt, Faraday's law, to calculate that. Okay, you know electric uh, EMFs dimensions, you know times dimensions. So d phi by dt is electric EMF. So from that you can calculate phi's dimensions as well. I hope Madan S, that is clear. Okay, now these are the applications. These are important as theory points, so you should definitely go through this. More importantly, this microwave, okay, how the microwave works. So microwave oven, you might have all used microwave oven, and you might have wondered, okay, why you cannot put an electric sorry, why you cannot put a metallic object inside microwave. Have you ever wondered? And that reason has been mentioned over here. So this paragraph is very important. So for that, you need to understand how a microwave oven works. What does a oven work on it? Basically, there are microwaves which are created, and the frequency of these waves match. It's clearly mentioned. Okay, in such ovens, the frequency of the microwaves is selected to match the resonant frequency of the water molecules. Water molecules. So, whichever water content is there, those water molecules will resonate with the microwaves. And because of which the food which contains that liquid, obviously that will also get heated up. Now it so happens the resonant frequency of the other plastic, ceramic objects, they will not match, and that's the reason why those objects will not get heated up. Those objects will not get heated up. Okay, so I hope this is clear. Sri Rashi, please concentrate on the session. You guys are wasting time thinking about when the JEE examination will happen. Please do not watch random videos every day. When will JEE happen? That is going to kill your time. I know a lot of people will create a lot of videos, but here, if you have seen, I just created one video back in December, and I've told you the announcement will only happen after Christmas, and we are expecting the dates only in March, not before that. So please concentrate on the lectures, please concentrate on your development and studies right now. Okay, all right, so moving ahead. Hello Manikadan, Arch Fab 73, please put up a comment after the video and I'll definitely let you know. And this entire paragraph as such is important, how microwave oven works and everything, and why you should not use metallic objects, because if the metals also get the metal ions, if they get vibrated because of the microwaves, the charges on that metallic object will get knocked out, and those charges will get accumulated on those metallic containers, and that will definitely create a shock the person who will be touching that metallic object. So that's why you should not put a metallic container in the microwave. Very, very important. Okay, now going ahead, infrared waves, you should just go through this passage as well. Please go through it. And also visible rays, I just told you about it, that you should just know what's the range like. And basically you should just know that most of the living organisms can see visible rays, but there are things like snakes and dogs and etc. who can see much beyond the visible spectrum. Like for example, snakes can detect infrared waves. UV rays, you should know about it, that it is harmful for the skin and can cause diseases, obviously. So you should definitely protect yourself from it. And the ozone layer obviously protects us from the UV rays. X-rays, there is a separate chapter. Gamma rays also, there is a separate chapter. Okay, these two are separate chapters in term 2. I hope you know that. This is also a separate chapter. It is there in nuclear physics. It's there in nuclear physics. So you'll learn more about it. But yes, there is no harm in going through those things. Just go through the table. Okay, but not so important. That's why I'm not marking it. And then obviously you should definitely go through the summary of every chapter once that is done. The summary and the points to ponder. Okay, so please go through all these things. You can have some very specific theory pointers which can be asked in the boards or probably in your JEE examination, even JEE mains. Let me tell you that. Yes, you can get that. You'd never know. Okay, so please go through it. Are you guys now ready for solving some questions? Yep. Are you guys now ready for solving the questions? Please put up a yo, or please put up a smiley, please put up a fire emoji. That will make me realize that you guys are now ready and you guys have understood what is important in this chapter. It's a small, sweet chapter, scoring chapter. How many of you feel that this is a scoring chapter? Yep. How many of you feel that this is a scoring chapter? I should not leave it. How many of you realize that? Yep. You guys see that? It's a very important scoring chapter, small, sweet chapter. It's not that difficult. Yep. Sankar realizes it. Madan also says, yo, yes, Karan. Very true, Akash. Yep. So what is the difference between UV rays and UV light? It's the same thing. Rays is more specifically a rays having a direction. It's like an arrow mark. Okay, it's like a vector pointing in particular direction. Light is a more generic term. Okay, Ankit. I hope that is clear. Yes. Let's get going then with the questions coming up on your screen. Get ready. Let me also tell you, if you have forgotten to write the JEE Ekalavya test which just happened today, then there is one last chance which is going to happen next week. Ekalavya is the JEE Advanced batch which is starting, okay, towards the end of January, and this batch you can register for free. You have lots of assignments, amazing teachers, and obviously lots of test series and lots of modules which will make sure that you conquer JEE Advanced. So go ahead, check out the link which is there in the description box. Register yourself, because there is one more attempt for the Ekalavya entrance test, because after that the entrance will only happen after the first JEE mains attempt. Okay, so here's your first question on your screen. Match the following previous year question which was asked in April. Come on, let's see how many of you can do this question. I'll just make it a little small. So optical fiber communication, radar, sonar, mobile phone. On the right side, you have ultrasound, infrared, microwaves, and radio waves. So what do you guys say? Okay, okay. So come on. Laser beam. A beam means it's confined to a specific location, and it's a collection of rays. Light could be in any particular direction, it could be in any random direction. There is no need of it to be in a form of a collected manner. Okay, so that's the difference. So beam is a collection of rays flowing in a particular direction. It's a collection, but light is a generic term. Okay, it could be a ray, it could be a beam, it could be scattered, doesn't matter. Okay, so what do you guys think? Is it A, is it B, is it C, is it D? Okay, some of the options are deliberately chosen in such a way, or applications, that you might not even find it in NCERT, but because you can figure out what other applications are or how other options will match, so by elimination you can figure out what should be the correct application. In case you do not know, let's say, the application of optical fiber or what wave is used, then it's okay. You can try it out for radar or sonar or mobile phone, and if you know those, then by elimination you can get it for the other thing. Okay, so let's see. Many of you are saying C and D. Confused. Dakshin saying A. Come on, my warriors. Think. Karan saying C. Well, the correct answer is actually C. All right. So radar. So for radar, what do you do? So for radar, you use long radio waves. You might have seen those radars. Okay, in aeroplanes or in an airport or in military applications, they use radio waves. Okay, so that's why it is. Uh, okay, so I hope this is clear. Then you have sonar. Sonar you would have heard in its application in ships. Basically, in the ship at the bottom there is a transmitter. It transmits high frequency sound waves and it gets reflected. You would have learned this back in science books when you are in 8th or 9th standard, and there is a receiver. Based on the time difference, you can find out the depth of the ocean floor. So sonar is based on high frequency sound. This is sound, by the way. Ultrasound is sound, it's not light. Okay, so that's what it is. Then mobile phones. Well, what is mobile phone? Mobile phones are very short wavelength, very high frequency, so they are microwaves. You can think of it that way. And yes, optical fiber communication is infrared communication. Okay, so it is IR communication in general. So they use infrared light. Okay, so that's how you can eliminate and figure it out. So these are very much theoretical. Moving on to the next one, which was asked in 2020 JEE. Okay, let's see how many of you can get this. How many of you can get this? Figure this out. So different kinds of light waves are given, and you have been asked what should be their approximate wavelength. Think. Yes, in history, Second World War, you read it very good, Sankar. You are fond of history and looks like you remember it very well. Good. Hi, Jatin. Welcome aboard. Come on, come on, come on. Figure this out. Microwaves, what do you think is the approximate wavelength? Gamma rays, what's the approximate wavelength? AM radio waves, what's the approximate wavelength? X-rays, what's the approximate wavelength? Come on, you should be able to get this. It's not that difficult. Figure this out. What do you think is the answer? Okay, so go by elimination if you do not know anything. The best is always go by elimination. X-rays, I told you, it is generally in Armstrongs, and Armstrongs means 10 to the power minus 10 meters. So D should go with, think about it, D should go with third option. D should go with third option. So like that, there are only two options, A and D. So B and C automatically get eliminated. D should go with third option because X-rays is always in Armstrong. Correct? Now you can go for any other things like AM radio waves. These are long waves. Long waves means it will be in meters. So you can see there is only one option like that, 100 meters. So C should go with 1. C should go with 1. Naturally, A will also get eliminated. So the only correct option will be D. Correcto. You can see gamma rays will be very small wavelength. So they are very, very small wavelength. And microwaves is in the order of 10 to the power minus 3. So A goes with 4. And then you have gamma rays in the order of 10 to the power minus 15, which is 2. Long radio waves, option 1, which is 100 meters. And X-rays is in Armstrong, which is 10 to the power minus 10 meters. So straightforward, that's how you do this question. So moving ahead to the next one. The microwave oven acts on the principle of, what do you think does the microwave oven act on? Which principle do you think it acts on? Giving rotational energy to water molecules, giving translational energy to water molecules, giving vibrational energy, or transferring electrons from lower to higher energy levels in the water molecule? What do you think? Microwave 4, okay. Sankar saying D. Balaji, come on, think. Bachalok, what do you think is the answer to this question? Microwave oven, what principle do you think it is based on? Rotational energy, translational energy, vibrational energy. If you have read the NCERT, if the NCERT is in front of you, you can get the answer immediately. And this was asked in 2016 April JEE examination. So you can see that they asked direct questions from this chapter, theory questions also. So if you have read through NCERT, you know it. Come on. Okay. So in case you have forgotten, it's okay. Let me also show you where it is. It's right there in NCERT. So if you go up in NCERT, you will see there is a beautiful paragraph on microwave oven, which I just showed you. And you can see that it is clearly mentioned the frequency of rotation of water molecules is going to match with the frequency of the microwaves. It's the frequency of rotation. Do you see that word rotation out there? Yep, do you see that word rotation out there? It's clearly mentioned in that paragraph. So hence, my warriors, the correct answer to this question should be nothing but giving rotational energy to water molecules. Got it? So that's where it is there. It's clearly mentioned in NCERT. So that's why you should read NCERT carefully. If you have read it, you know it. So go through it multiple times. Understood, my warriors? Loving these questions. And I hope you are realizing the intricacy of these discussions. Moving to the next question. Let's see how many of you can get this. If you have an EM wave and the direction of electric and magnetic fields are given, what do you think is the unit vector direction of propagation of that wave? Where do you think that the light wave will propagate? Come on, let's see how many of you can get this. I'll give you a hint. If you have electric field and if you have magnetic field, okay, if this is electric field and if this is magnetic field, there is only one particular way the speed of light can be. Guess what? Electric field is always perpendicular to E as well as B, but the speed of light is always perpendicular to E as well as B, but which direction will it be perpendicular? Because you have both ways where you can drop perpendicular. The answer is always go via E cross B direction. So the speed of light So speed of light is always parallel to the vector E cross B. Keep this in mind. So wherever E cross B is, that's where it will be parallel. So basically it will be in this direction, E cross B. All right, so let's do this now and figure this out. What should be the correct answer? So E cross B, I believe, will be K hat cross 2, correct, I cap minus 2 J cap. And I will just, for your convenience, I'll just write down I, J, K over here. Remember, if you go clockwise, it is positive. So K cross I will be plus 2 J cap minus K cross J will be minus 2 I cap. So hence it will be 2 I cap plus 2 J cap. So basically you have 2 times I cap plus J cap. So you need I cap plus J cap somewhere. So all the other options are going to get eliminated. I cap plus J cap is only there over here. So option A should be correct. I hope this is clear. Oh my God. Oh my God. Shivan, thank you, Bacha, so much. And I hope your NIT Calicut journey is going on well. I hope you had a great freshers and your semester has just started. I don't know. How is it? And are you liking it? How is the campus? Probably you can tell your juniors to study well because 12th standard students, just a couple of few more months, and then they will be also probably in your shoes. Yes, Dakshin, you can join my. Oh, by the way, I'll be teaching in the crash course in case you have forgotten about it. Yep, yep, yep. So I'll be teaching in the crash course as well in few of the classes. And yes, you can definitely join in the crash course. And if you're in the 11th standard and are wishing to join the 12th standard batch, yes, please join it as soon as possible because I'll be teaching in the 12th standard batch as well. Definitely. All right, so let's get moving to the next question coming up on your screen. If epsilon naught and mu naught are permittivity and permeability of vacuum, and epsilon and mu is just permittivity and permeability of the medium, what do you think is the refractive index of the medium? Okay, so right now, Zayad, I'm in Pune. Ankit saying B, interestingo, quick. Ankit was very quick about this. Let's figure this out. Refractive index. What is refractive index? It is speed of light, okay, in vacuum upon speed of light. Oops, 1 second. Speed of light in vacuum upon speed of light in the medium. I just gave you the formula for speed of light in vacuum and medium. Do you remember that? It was 1 upon, for vacuum it was mu naught and epsilon naught. And for medium, instead of mu naught and epsilon naught, it was just mu and epsilon. So if you just do the simple math, you can clearly see it is mu e on the top and mu naught epsilon naught below. So is that option there somewhere? Yes, it is there. Yep. So very good, very good. So Dakshin, yes, if you are a 11th standard student who is moving to 12th, then there is a good chance you will be in my batch. So make sure you are in the current 11th standard batch. Yep. Yep. Wow, Jagnesh Vankat is saying that I got this question in today's exam. Very good. So you can see these questions are important, bacha. And I hope you got it correct then also. Alpha God, Pathfinder, I know it's a book. Pathfinder book is relevant for Olympiads and such examination, but our series name is Pathfinder. It has no relationship with the Pathfinder book, and this Pathfinder series is for JEE mains, JEE advanced, as well as BitSat kind of examinations for basically all the 12th standard students. All right, got it? So let's get going. Moving on. Yes, Pranish, if you get 99 percentile and above, definitely you can join the Ekalavya batch, and I really hope you can get uh, get into Ekalavya. Definitely, please make sure you work really hard. 99 percentile and above, you will be very happy. I'll be very happy for you. Okay, next question. Intensity of the electromagnetic wave is given by which of the following formula? Okay, so Dakshin, basically what will happen now, all the batches are will be over in 11th standard. So obviously new batches will start. You will be now mixed when you go from 11 to 12. So new batches will start, right? So you might not have the same batchmates. You will have probably a mixture of many students. Yes, there is a good chance if you do well, but make sure your performance in the next few tests of 11th standard is well. Only then you'll get into my batch. Okay. All right. So let's see. Uh, Ankit, um, it's just like a practice exam. Otherwise, there is no use of NDA. But apart from that, if you are interested to join the defense forces, only then give NDA. Other than that, there is no point. Okay, option D, is it? Really? Think about it. Let's see, what is the formula for intensity? The formula for intensity was half, E naught B naught by mu naught, correct? Now, if you try to recollect any other formula, then you will see C was also E naught by B naught. Also, C was 1 by root mu naught epsilon naught. So you can see E naught is equal to C B naught, or basically B naught is equal to E naught by C. This is one way. And over here, if you square both sides, you will get 1. C square is mu naught epsilon naught below. And you can also write other forms. Now let's see if I can get into some form over here. So if I just play around with this intensity, I will get, so just try to replace B naught. Okay, just try to replace B naught and see what do we get. I'll get E naught by mu naught. Instead of B naught, just put E naught by C. Just put E naught by C. Just put E naught by C. Okay, so now I've just got it from here. B naught is E naught by C. So now I'll get half E naught square and by C, and instead of 1 by mu naught, let's just see what do we get over here. 1 by mu naught from this side over here will be nothing but C square epsilon naught. It will be C square epsilon naught. So over here, instead of 1 by mu naught, I will replace it by C square epsilon naught. So I'll get half E naught square by C square epsilon naught, which is half epsilon naught square C epsilon naught. I don't think D option is matching. D option is not matching, guys. I hope this is clear. Okay, so just see this option D. Definitely it is not matching. Probably we need to get rid of something else. Maybe we'll get rid of E naught then. So let's try and get rid of E naught. I'll just draw it with different color now. So intensity will be half B naught by mu naught. Instead of E naught, I can put it as CB naught. I can put it as CB naught, correct? Instead of E naught, I've just put it as CB naught. So I'll get half C B naught square, and I have 1 by mu naught. And what is 1 by mu naught? From here, 1 by mu naught is nothing but C square epsilon naught. So I'll get 1 by C cube epsilon naught B naught square. Is that option matching with something? Yes, Ramya, you got it. Oh, it's not C. No. It is not C, Ramya. It is option B. It is option B. Be careful. In option C, that 2 only is not there. Where is that 2? Where is that 2? 2 only is not there. Hence, C is incorrect. Got it? So, it is C cube epsilon naught B square by 2. It's all about playing with the formulas. Yep. It's all about playing with the formulas. Nothing else. Okay. Beautiful question. You can see option B is correct. Okay, moving ahead. So what are the formulas that we have used over here? In fact, 3 formulas. Do you see that? There were 3 formulas. This was the first formula. This was the second formula. And this was the third formula. So combination of 3 formulas. This can be a good question for JEE, and many students will probably make some mistake or just skip it. Moving on to the next one. Coming up on your screen. Now this is straightforward. You should be able to get it. The average energy density of an electromagnetic wave given by this equation will be approximately, come on, yes, galti se mistake, and you're allowed to do that galti se mistake, it's okay. Oh my god, thank you so much, Faisal, Shibin, it means a lot, and it shows your trust, it shows your faith, and that's what it is at the end of the day, warriors. Like, you should have faith in the system, you should have faith in the teachers, you should have faith in yourself. When you have these 3 F's, trust me, I mean, you don't have to worry about many of the things that are going to come on your way. You will just be so confident and you will never be demotivated. These 3 F's, remember that. Oh my god, Priyanshu, you are a little bit late, but you can definitely watch the replay. Right now we are in questions. Try to attempt these questions and then watch the remaining part later on, Hannah, And in fact, I'm going to also give you the PDF of the NCERT, my handwritten notes. You guys were always asking, Shreyas sir, we want your handwriting is so beautiful, sir. So many people used to tell me this, and they always wanted my handwritten notes. Isn't that right? You always wanted my beautiful handwriting notes. So let's see whether you guys can get this now. Ankit, you will, you trust me, it's a very good decision what you've done. Blindly follow. You'll see where you will reach within few months. Okay. All right. Rame, yes, there are programs for JEE from 9th standard as well. It's called Foundation. Yes, it is there. It is there. Good evening, Sugesh. Now, average energy density. What is the formula for energy density? I just gave it to you. Half epsilon naught E square. Correct? And what is the value of epsilon? Permittivity for free space. It is 8.85. Do you remember it? Electrostatics into 10 to the power minus 12. Electric field. Electric field will be how much? It is 50, right? So 50 square. Just keep this out here, and that's it. So just do the math approximately, just see how much will you get approximately. Just order is important. We are not interested in the values out as such. So 8.85 will almost approximately become 4.4 into 5 square is 25 into 10 to the power minus 12 into 10 to the power 2. Where this 10 to the power 2 came from? When you do 50 square, it is nothing but 5 square into 10 square. Okay, so that's where this came from. I hope this is clear. Okay, so this 4 into 25, how much is 4 into 25? Almost like 100 again. It is 100 into 10 to the power minus 12 into 10 to the power 2. So approximately are you getting 10 to the power minus 8 joules? No, it's not D. It's not D. Yeah. Okay. Okay. Good one, Thalapathy Giri though. Okay. Okay, so joules per meter cube. Yes, that's the answer, 10 to the power minus 8. I'm not sure where you guys made mistake. In case you wrote 10 to the power minus 5, just check where you made a mistake. Okay. Oh yes, we have Mallus also over here. That's why I can see the words chetta, chetta and chetty. Very nice way of calling bros and sis. So in English, during our generation we used to call dudes. Okay, we used to use the word dudes, and yeah, and now you are a generation of bros and sis. So, and yes, Mallus are always constant. Chetta and chetty. During my times also, they used to call chetta chetty, and in Tamil Nadu, yes, it's all about das, right? And in Andhra Pradesh, it's all about ras. So we have all the alphabets. We have chetta, chetti, ra, da, yep, enada. Yes, enada. I know that. Okay, very good. Okay, so I don't know what else is there. Probably in your region, you can definitely let me know in the chat box down there. Moving on to the next question coming up on your screen. A plane electromagnetic wave has a frequency of this much and energy density of this much. Amplitude of the magnetic field is approximately how much? Amplitude of the electromagnetic wave is approximately how much? Okay, let's see. Okay, so frequency is known, energy density is known, magnetic field's amplitude has been asked. Think which formula are we going to use? Guys, energy density is given. Energy density of magnetic field is half, okay, and then you have B square by mu naught. There you go. You already have that formula. Okay, so Akka and Anna. Oh yeah, that's bro and sis, but like in slang, I think when you call your friends, you call da. Yes. Yeah. Okay, so now let's just rearrange, and then what do we get? B square is equal to 2 mu naught into rho. Now everything you know, guys, mu naught's value, you don't need all these rubbish. 1 by 4 pi epsilon naught and C and all that. You know the value of mu naught, it is 4 pi into 10 to the power minus 7. Rho B, rho B, rho B, rho B, rho B, density is 1.02 into 10 to the power minus 8. That's it. So B will be root of all these things. So 2 into 4 is 8 pi into 1.02 into 10 to the power minus 15 in order to make it even powers of 10 so that it is easier to take the root. So you can write it as 8 into 3.14 into 10.2 into 10 to the power minus 16. So this you can calculate approximately. So 80 into 3 will be 240. So it will come very close to 256, guys. And root of 10 to the power minus 6 is 10 to the power minus 8. This is approximately. This is approximately. You can see that 8 threes are 24, 24 into 10, 240. It will be slightly more than that. So 256, very close to 256. Root of 256 is nothing but 16. 16 into 10 to the power minus 8. So this is nothing but 160 into 10 to the power minus 9, which is 160 nano. 10 to the power minus 9 is nano Tesla, which is option B. Very true. Correcto. Oh, let's not get to Harshita Shriva. Let's not get to UP things out here. Yeah, for that you should watch Netflix. Yeah, and let's not get there. Yeah, so this is a channel for kids. So let's keep it sober. All right. Okay. Cool. Very good, Ankit. Very good, Shruti. Sir, if you're solving HC Verma and Irodov and Bansal sheets, can we get under a All India rank 100? I think AlphaGod, I replied to your comment also. Yes, you can. You can definitely get, but you need to solve PYQs additionally. Apart from that, yeah, solving papers, mock tests are very important. Apart from these things, but if you master these three books, master all these questions from these books, yes, you are at a next level. And yes, mock tests and then PYQs. So do this for sure. 100 below 100 rank guaranteed. Okay, let's have a look at this question now. Coming up on your screen here, you have to find almost each and everything in this question, and let's see how do we do this question out here. So E naught is given, frequency is given, find B naught, omega naught, K, lambda, E, B, everything. Yes, electron. Oh, yes, Ramya, thank you very much for reminding me. EM waves are added in JEE Advanced now, but that is from 2023 onwards, not this year. Yep. So for all, and especially you are young, yes. So for you, definitely it will be there, and who knows what else might be there by the time you write JEE Advanced. All right. So the first formula that I'm going to use is E naught by B naught is equal to C, and we want to find B naught. So B naught will be E naught by C. So it will be E naught. E naught is 120. C is 3 into 10 to the power 8. So this will be 40 into 10 to the power minus 8. And yes, you can write it as 4 into 10 to the power minus 7. Or you can also write it as 400 into 10 to the power minus 9. Reason is 10 to the power minus 9 is nano. So it will become 400 nano Tesla. That's the value of B naught. So that's one answer which we got. Correct? Yep. So that's one answer, guys. We got one answer over here. Oh, very nice. I got highlighters too. Yep. Oh my God. Ramya, you just, I don't know, maybe by the time you write, maybe black holes and God knows relativity also gets added and it will be fun, right? All right. So let's move on to the next one then. What else is there? Oops, I changed the highlighter color to something else. Okay. So what do we have now? Yep. So omega naught. So I think we can find omega naught K and lambda together. Frequency is given. So from that wavelength can be easily found because frequency into wavelength is speed of light. So lambda will be 3 into 10 to the power 8 divided by frequency, which is 50 mega, which is 10 to the power 6. Okay. So which is 3 by 5 into 10 to the power 8, 10 to the power 7, so only 110, 30 by 5, 30 by 5 is 6, so lambda is 6 meters. So this is another answer which we just got, we just highlighted. So lambda is also done. Next, out here, what else is there? We have to find out, what is that? Oops, not this highlighter. So next we have to find out K. Okay, K and omega naught. So omega naught is 2 pi f. Use the standard form. So 2 pi into frequency. Frequency is 50 mega. So 50 into 10 to the power 6. So pi is 3.14. So 3.14. 50 into 2 is 100 into 10 to the power 6. So this will become 3.14 into 10 to the power 8. And if you want, you can write it as 314 into 10 to the power 6, because then it will become 314 mega radians per second. Mega radians per second as well, or I don't know, you can just leave it over here as well, radians per second. So this is one answer for omega naught. So I'm just highlighting this as well. Okay, so many answers done. Next, what else is there? Yep, K. So let's find out K as well. K will be omega by speed of light is omega by K. So K will be omega by C. So omega is 3.14 into 10 to the power 8, and C is 3 into 10 to the power 8. So K will be roughly slightly more than 1, maybe 1.03, 1.04 or 1.05. So roughly 1, but the radian per meter. Slightly more than 1, but okay. I hope this is clear. Yep. I hope this is fine. So yes, I have written 3.14. This point is there. I don't know whether you can see that. This point is there over here. Okay. This point is also there over here, but that point is not there over here. Okay. Fair enough. Last few things. You have to write the equation of the wave, E and B. Remember, E is E naught. Okay. E naught sine. You can write kx plus or minus omega t. Now it is not exactly mentioned which side is the wave going, so I cannot choose the sign. Yes, just substitute. So E will be equal to 120 sine k value we just found out to be 1. Okay, so 1x approximately, this is plus or minus omega. Omega we just found out to be such a big number, 3.14 into 10 to the power 8. So 3.14 into 10 to the power 8 into t. So this is what it will be. Why I don't know whether it is plus or minus? Because it depends on which direction it is going. I don't know the direction. Okay, so that's why I have to leave it like this. If in the question it was mentioned positive x-axis, then which sign will you choose, plus or minus? Plus or minus, Chinmay, expect it in March. Then will you choose plus or minus? Then you will choose minus. Keep this in mind. And when it is on the negative side, then you use plus. Okay, so that's how it works. It's completely opposite. Okay, completely opposite. Keep this in mind. All right. So having said that, last thing, similarly, you can get the value of B as well. Let me just move myself a little bit, and you can get the value of B. B will be B naught. B naught is 400 into 10 to the power minus 9, and same thing, sine x plus or minus 3.14 into 10 to the power 8t. That is the answer. Is that understood, my warriors? Did you guys get it how to solve the question? Okay, did you guys get it how to solve the question? So what an amazing session. I mean, really. Yeah, so all these answers also mentioned over here. Now I have kept some homework questions for all of you. These are the questions which you are supposed to solve, so that in the house you have adequate practice, and then you can immediately apply the concepts whatever you have learned today. That is very, very important, guys. So you please try to solve it today itself. Don't waste your time, and make sure you post the answers in the comment section. This is your second homework question. Okay, please put up the answers. This is also homework. I will just put it up right over here. Okay, and let me also show you what and all you can get from our crash course, which is right now running for all the 12th standard. You'll get 20 mock tests, then you will get 90 live sessions plus their recordings, plus all India level test series with rank comparison with previous all India ranks, also unlimited doubt solving, and also assignments for each and every chapter. So many questions that you will be definitely kept busy. If your aim is 99 percentile and above, no matter where your preparation level is, this crash course is exactly for all of you. And the usual price of this crash course is 20,000 rupees, but on offer you get 50% off and you get it for 10,000 rupees. But since you're attending my class today, you get extra 1,000 rupees off. That means you get it for 9,000 rupees only. So there is a link which is there in the description box below. I'll just show that to you. So if you're watching this video right now, all right, so just open up the description box. You can see JEE crash course. Even there is a CBSE term 2 full syllabus preparation. You can click on that link as well. And you can see that course is also available for very affordable prices for all of you. Okay, so 11,699 rupees. You can even try it out for 15 days for just 899 rupees as well. That's for CBSE term 2 complete syllabus. It's not a crash course, it's a complete syllabus course. Now here in JEE crash course, you get an option to choose 27th December batch or 10th January batch. I would say choose anything. It doesn't really matter. Okay, you can choose the 10th January batch as well. Make sure that 10th January batch has started today. If you want to end the sessions earlier, then you can join the 12th February batch. Remember, the validity is valid till the 4th attempt, even if it gets postponed. And you can also find me in the JEE crash course. Make sure you do not miss my class whenever I conduct it in the crash course. All right, so you can see you'll get extra 10% off using my coupon code. So all the details have been mentioned here. Whatever I just told you, this is one thing which you should attend, because even if you have joined a coaching, remember the crash course is definitely going to boost your performance. Even if you don't attend the live classes, I would say the mock tests, the test discussions, the assignments, the doubt solving, that is going to be a very big plus point for all of you to boost your score. All right, so that's the reason why I should join the crash course, even if you don't want to cover up the syllabus as such. Okay, so there are many students who are probably well versed with the syllabus. They are wondering, sir, should I join the crash course? Yes, you should definitely join the crash course. Thank you very much for joining in. Um, yes, I'm done. And yep, when can I expect? I just mentioned you, Chidmay, probably somewhere around March. Yep, yeah, initial March, first half of March. That's when you can expect it. Yes, you can join the Ekalavya after the first JEE mains result, but for that you need to have 99 percentile and above. And Sankar, if you are a NEET aspirant, on the top itself you can change the course. I don't know whether you know that. You can change the course name right over there on the top. So there are okay, right now I don't know why it's not showing, but yes, there is yeah, there are options where you can change the course to NEET crash course, and there is a NEET crash course also running, bacha. Okay, right now it is not showing for me, probably I don't know why. So just check it out, it will definitely show it to you. Okay, so thank you very much for joining in today, bachalo. It was amazing. It was a good one-shot session with all of you. We have completed so much, not just the NCERT notes, but also underlining and all the important formulas. Plus, we have practiced a lot of questions. And please watch lecture 1 of electromagnetic waves in case you want more additional inputs as well. Again, I'll be conducting one-shot NCERT underline with handwritten notes plus problem solving for light waves. Do you guys want it? Please let me know in the comments. And yes, whatever you want next week, please put it up in the comment section. I'll be reading all of it. Okay, so yes, we are going to start with ray optics also next week. Okay, light waves one shot coming up just in the next few days. See you. That's it from my side. Have a great time. Stay safe, stay healthy, stay protected, study well, work hard, sleep less, but sleep enough. Yep, and keep attending my classes live. All right, and even if you're watching it recorded, I'm still proud of you. All right, but watch it. That's it from my side. This was Captain Shreyas going live. Hasta la vista. Signing off.